Hello, we're going to take a look at 8.3, which is rational functions and their graphs. We're going to have a lot more graphs than this functions and answering questions off the graph. So make sure you have a graphing calculator so we can go ahead and graph them. So for this first one, we have y equals x plus 3 divided by x squared minus 4x plus 3. Now, when we're typing this into our graphing calculator, we can type it in just like this. But when we're writing it down, I want to make sure that our first step that we're going through and factoring this, because as we're answering our questions, the factored form may be helpful. So x plus 3 on top does not factor, so I'm just going to leave it the same. But on bottom, we can factor this, so we have x and x. We want to see our a times our c, 1 times 3, what multiplies to 3 but adds up to negative 4. So we'd have negative 1 and negative 3. Notice it adds up to negative 4, but it multiplies to positive 3, so this would be our factored form. So then we're going to go through, and let's still graph it on our calculator. And again, we can type it into our calculator factored form, or as just the original problem. So we're going to put what's in the numerator in parentheses divided by what's in the denominator in parentheses. So we get this graph, and I'm going to make a sketch of it so we can kind of use this sketch to our advantage. Alrighty, so our domain, the first part is, if you think back to 8.2, our domain, we want to find our vertical asymptotes, because whatever our vertical asymptotes are, then those are going to be our restrictions. So right here, notice when we factored it, if we set those equal to 0 and we solve for them, we get x equals 1 and x equals positive 3. So those are going to be our vertical asymptotes at x equals 1 and x equals 3. So since those are our vertical asymptotes, those are our restrictions on our domain. Our domain is all real numbers, but x cannot equal 1 and x cannot equal 3. Now the points of discontinuity, that is where are there breaks on my graph? So where is it non-continuous at? So whatever my domain is, those, the opposite are going to be my points of discontinuity. Because notice right here at 1, I had to pick up my pencil from going from here to down here. And then right out here at 3, notice I had to, if I'm drawing this, I had to pick up my pencil to come up here to keep drawing it. So there's a break at my graph at x equals 1, and there's another break at x equals 3. So those are my points of discontinuity. Now in your assignment, it's going to ask you to tell whether those are removable or non-removable. So in factored form, notice nothing cancels out. If this was x plus 3 and this was x plus 3, those would be able to cancel out, so then I would say it's removable. But nothing cancels out, so both of these are considered non-removable. For my x-intercept, if I go through, I want to see where it crosses the x-axis. So I can do this a couple different ways. I can either set my numerator equal to 0 and solve for it. So that would be one method that I could look at my numerator, set that equal to 0, solve for it, and I get negative 3 then. So my x-intercept is just x equals negative 3. Another way I could look at my graph and do the left bound, right bound. So if I go to second trace, go down to 0, and I want to see where it goes below that y-axis, click enter. Then I want to go back above it, click enter, and right here at negative 3 is where it crosses. For my y-intercept, I want to know where it crosses the y-axis. So I can look at my graph, go to second trace, go to value, type in 0 for my x, and see that my y-intercept is 1. So I could do that. Or another way that I could do it, let x equal 0 and then just simplify. So I could plug in 0 for all of my x's in either factored form or not factored form and then solve for it. So if I do that, I would have 0 plus 3 divided by 0 squared minus 4 times 0 is just 0 plus 3. Go ahead and solve for that, and I get 3 divided by 3, which is 1. So either way, I can do it by hand or just looking at the graph. So let's try another one of these. So for this next one, we have x minus 5 divided by x squared plus 1. Neither the top nor the bottom factors, so I can't go ahead and factor, so I'm just going to go ahead and graph it. Okay, and then I'm going to attempt to draw that. Okay, and then we want to go through and answer the questions. So our domain is we're looking to see where I can make that vertical line that my graph approaches but does not cross. And notice it's continuous the whole way. There is no place that I can make a vertical line that approaches that does not cross. So my domain is just going to be all real numbers because there is no vertical asymptote, so there's no restrictions. My points of discontinuity, again, I do not have to pick up my pencil at all when I make this graph, so my points of discontinuity are none. And then I want to find my x-intercept, so where it crosses the x-axis. So I go to second trace 0, and I want to see where it crosses the x-axis. So if I zoom up, I want to go below, and then I want to see where it goes above there. Click enter, enter. And it crosses at 5. Okay, another way that I could do this, if I'm having a hard time seeing where it crosses the x-axis, I can just set my numerator equal to 0. So when I set this equal to 0, I solve for it, then I get x equals 5. For my y-intercept, I want to see where it crosses the y-axis, so I'm going to go to second trace, go to the first one, value, type in 0 for my x, and my y equals -5. Another way that I can do this by hand is just plug in 0 for all of my x's in this equation. So I have 0 minus 5 divided by 0 squared plus 1. So I get -5 divided by just 1, which reduces to -5. For the next one, I have y equals x squared minus 3x minus 4 divided by x minus 4. I want to go ahead and factor it. So I have, notice just I need to find what multiplies to -4 but adds up to -3. So I get -4 and a +1. So I plug that in. And then for this one, then my x minus 4s do reduce out. So that's going to play into effect for our answers when we go through and answer them. So reduced form would be x plus 1. Let's also take a look at the graph. Alrighty, so I'm going to draw this graph for us. And then for this one, the domain is all real numbers. Notice I have the restriction of x cannot equal 4. Looking at your graph, it's really hard to see that x cannot equal 4. So if I go to second trace and I put my value, go to the first one, and I put x equals 4, what does my y value equal? Notice the y value is blank. There is a hole at x equals 4, and it's really hard to see that hole unless you zoom in on your graph. So how I know that x cannot equal 4 in this one, the reason for it is when I set my denominator equal to 0 and I solve for it, x cannot equal 4. Okay, the reason for that, 4 minus 4 is 0, and I cannot divide by 0 in the denominator. So my restriction is x equals 4. The reason that we cannot see it, down here at points of discontinuity, it's going to be the opposite of this. So since x cannot equal 4 here, that is my points of discontinuity, is x equals 4, the opposite. And the reason we can't see it is because it's removable. In factored form, it cancels out. So when it is removable, it cancels out. You're not going to be able to see it. It's not going to be a clear vertical asymptote like above when it was non-removable. So when it's removable, there's just going to be a hole in that spot, so you definitely need to be looking at it. And if it's removable, then you still need to set that denominator equal to 0, still solve for it. Just know that there's going to be a hole at that spot. Okay, my x-intercept, where it crosses the x-axis, I'm going to go to second trace. I'm going to go to 0, and I'm going to go below the line and then above it and see where it crosses that x-axis. It crosses at -1, and then I'm going to go to second trace. I'm going to go to value of 0, see what my y value is 1. So my y-intercept is 1. Another way that I can solve for both of those is to solve for the x-intercept. I just set my numerator equal to 0. Now notice for this one, if I set both of them equal to 0, I'd have positive 4 and negative 1. It does not cross, though, at positive 4. And the reason for that is because it's removable. So it only crosses the y-axis at the negative 1. And then for my y-intercept, how I could do that, just looking at my equation, I could plug in 0 for all of my x's and go ahead and simplify it. So I'd have 0 squared minus 3 times 0 minus 4 divided by 0 minus 4. So I get negative 4 divided by negative 4, which reduces to 1. So my y-intercept is 1. Let's do one more of these. So we have y equals 1 divided by x squared minus 16. So again, I want to go through and factor it. So I get 1 divided by x minus 4 times x plus 4 is the difference between two perfect squares. So I have a positive 4 and a negative 4. And then I'm going to go take a look at my graph. Okay, so we can see our graph looks similar to this. Okay, so our domain, if we set both of our factors equal to 0 and solve for them, we get positive 4 and negative 4. So our domain is going to be all real numbers, but x cannot equal 4 and x cannot equal negative 4. And that we can see right at 4 and negative 4, that's where our vertical asymptotes are, so that is going to be our restrictions. The points of discontinuity are what our vertical asymptotes are, so it's x equals 4 and x equals negative 4. Notice again, the opposite of this is what our points of discontinuity is, or our vertical asymptotes are the exact same thing as our points of discontinuity. Now in factored form, notice nothing cancels out, so both of these are going to be non-removable. Make sure you can have both of them being non-removable, both of them being removable, or one of each. For our x-intercept, notice it approaches this x-axis, but it never crosses it, so we're just going to put none. And then our y-intercept, if we go to our graph, we go to second trace, go to x equals 0, then our y-intercept is negative 0.0625. If we're going to do those by hand, how we can find our x-intercept by hand, set our numerator equal to 0. And when we set our numerator equal to 0, there's no variable to solve for, so hence it is none. And how we can solve by hand our y-intercept, we just plug in 0 for all of our x's. When we solve for this, we get 1 divided by negative 16. If we take 1 divided by negative 16 into our calculator, we get this decimal. The next type of problem that we're going to go more in depth on is finding the vertical asymptotes. So for this first one, our equation is y equals x plus 1 divided by x minus 2 times x minus 3. Now an easy way by hand to find the vertical asymptotes instead of having to take a look at the graph is just set the denominators equal to 0 and then solve for them. So if we set both of our denominators equal to, both of our factors equal to 0, we get x minus 2 equals 0, x minus 3 equals 0, so x equals 2 and x equals 3. So this one has two vertical asymptotes, one at positive 2 and one at positive 3. This next one, we have y equals x minus 2 divided by x minus 1 times x plus 3. We said our denominators equal to 0. We solve for them, so our vertical asymptotes would be a positive 1 and negative 3. To go more in depth on horizontal asymptotes, if we're looking at this first example, we're going to take a look at 3 different examples. We're looking at how we do it by hand instead of looking at the graph, is looking at the degrees. So for this one, we have 2x divided by x minus 3. Our degrees, our largest exponents, are 1 and 1. So when they're the same, we go and divide our coefficients, the numbers out in front. So the number out in front of this one is 2. The number out in front of this one would be 1. So we take 2 divided by 1, and we get y equals 2. For the next one, notice if we take a look at our degrees, we have x minus 2 and x squared minus 2x minus 3. The degree is 1 in the numerator. The degree is 2 in the denominator. The degree is larger in the denominator, so then it is automatically going to be y equals 0. For the next one, we have x squared divided by 2x to the first power minus 5. the degree is larger in the numerator. So if the degree is larger in the numerator, it's automatically going to be none. So I would make this chart in your notes over here to help you out with by hand how to find the horizontal asymptote. That if the degrees are the same, like this first one, you divide the coefficients. If the degree is larger in the denominator, like the second one, then it's automatically going to be y equals 0. And then if the degree is larger in the numerator, then it's automatically going to be none. Making this chart, you'll get to use this on your assessment is going to, if you're second guessing your answer, you can take a look at this chart, or if you're second guessing the graph, look at this chart and be able to have a second way to find the vertical and horizontal asymptotes.